Okay, let's go ahead and get started. So it's my pleasure to introduce our guest speaker today, Maria Esteva, who is a senior research scientist at the Texas Advanced Computing Center at University of Texas in Austin. Her work focuses on the design, implementation, and evaluation of data curation applications, and she's currently a data curator for the Core Trust Seal Certified DataSafe Data Depot Repository. And so today she'll be talking to us about curating national hazards data in DataSafe. So without further ado, please welcome me in joining, please join me in welcoming Maria Esteva. Thank you.
Okay, I'm going to share the screen with the presentation. And I want to say that I intend to make this presentation not very long. So I would like for it to be more of a discussion and question and answer. For this, I invited Joshua Fries, who is my colleague at TACC as well, and DesignSafe, and he's specialized in metrics. I thought that would be an interesting focus of this presentation, and so that he can answer more in-depth questions about that. But I will provide you with first an overview of the platform and our work, especially in curation and publication. So let me start the slideshow. Do you see the slides well? Okay.
Yes, perfect.
Okay, so let's get started with these. And I don't know how much you all know about DesignSafe. Many of you perhaps not, but it's a major cyber infrastructure project. It is, in fact, the leading cyber infrastructure for engineering research and education related to natural hazards. It serves experimental, field, and simulation data. It provides computational resources. It facilitates discoveries that are driven by AI, all of which with the focus of reducing the impacts of natural hazards on the built environment and communities. I have to say that DesignSafe not only it helps natural hazards engineering, but also social sciences. So it studies both the effects of natural hazards in the physical infrastructure and in the communities. It connects curated data sets from academic experiments and observations and simulations to the cyber infrastructure here at TACC, which are these supercomputers where people can conduct analysis, so both software and hardware, and we will talk more about that. But I will focus on the Data Depot Repository. I'm not going to talk about the larger functions of DesignSafe, except when we need to talk about them as integrated with the Data Depot Repository, which is my responsibility. The Data Depot Repository, which is certified repository, was designed, conceived with large-scale multimodal data in mind. So this is important to bear across the presentation. I also will talk about the community, our user community, as well as our team, how they have evolved throughout these years, and how they have responded to, or how they are responding to the services and the functions that we provide. And lastly, we will talk about how we measure all of these, or how we started measuring all of these, and what do we learn from these metrics. And we call them impact metrics. So first, I want to clarify a little, some points. And one of them is, what do we mean with large data in the Data Depot Repository? So I said, we designed these 10 years ago, focusing or thinking this is going to be large data. We knew that because we serve experimental facilities that produce a lot of data, large-scale experiments, large-scale observations. So you can see in the histogram, the distribution. And again, in the chat, or just be thinking about questions that you want to make, because I will kind of go quickly and then we can go in depth according to whatever you are interested in. So this histogram just shows project sizes. By project sizes, because this is focused on research projects which may have more than one data set, we are counting here the the sizes of data from one project, but that project, or individual projects, meaning individual projects, but that project may have more than one data set. So as you can see, we have considerably large data sets, most of which are simulations, because of course simulations output a lot of data. But I want to say that this is not just large size data sets and large size numbers of data points. We have this characteristic of these project timelines. Some of them are longitudinal projects. Some of them have multiple instances. For example, field research projects, they have deployment in the field, perhaps, right after a natural hazard, but then they go to the field various times to understand the aftermath of or the recovery of that project. Or we have large experiments that have different sessions or tests over time, and all of these can be in the form of subsequent publications, subsequent data set publications. So we have to deal with project timelines that are not just, okay, I produce a data set and I publish it. We also have multi-model data sets of diverse technical provenance. Here, for example, in field research, there will be deployment of multiple types of instruments that measure different things. And so all of these data sets from one deployment, one mission, we call it, one instance of that project, of that field observation project, will be very different and will have different technical provenance. Also, this is a multidisciplinary community within the natural hazards engineering, which they are all mostly civil engineers, but you will have people specializing in wind, people specializing in storm surge, people specializing in earthquakes, and within those, different phenomena, no? Some know more about landslides, others about earthquakes, others about tsunamis. So we say they are multidisciplinary, not to say also social science community. The social science community has very diverse interests, from health to, health to education to awareness of natural hazards and aftermath, recovery, recuperation, housing. So we have a very diverse group of users and data producers. So many of these are interdisciplinary projects, not just one focus of study or one phenomena, but multiple within a project. Sometimes we have social scientists and engineers deploying in the field. And the difficulty here, it's also, so the structure of these data sets is complex, but also there are no precise metadata standards except for social sciences. And so all of these complicates and make these large data even more complicated. By the design, since this DesignSafe is hosted at the Texas Advanced Computing Center, which is a supercomputing center that has been has been around for at least 2-3 decades almost in different iterations. So we are specialized in large data. We have supercomputers that can deal with large data. And the reason why we can host large data is because of where we are and because we can connect data to analysis or powerful analysis machines. So this is why I'm saying that this whole infrastructure is designed with that in mind. And the representation of these complex research methods and process was also, or is also, designed and conceived and developed with that in mind, with all the pros and cons and the complications that we will talk about. I want to talk about the team and the community. This is us, meaning the team that works for DesignSafe is a multidisciplinary team. for design and development. So we have, as you see in the Data Depot Repository team, we have a technical lead, we have people specialized in UX, UI design, we have Joshua, that is the data metrics developer, we have a search engine optimization developer, we have Fedora repository administrator, and then different specialties within the web development, and lately AI machine learning applications development. We are embedded in governance, especially Tracy and myself. We are part of the DesignSafe governance team. And also we are really embedded in the community. We serve primarily the NEARI community. It's an NSF initiative, Natural Hazards Engineering Research Infrastructure, which also has social scientists, but not in the name. And there are diverse experimental facilities, research groups that specialize in different things. And it's an expanding community because normally, traditionally it was specialized in earthquake only, then DesignSafe made it bigger, and we address wind and storm surge, but now we have more wildfires, and that's the next community. We have the social science community specializing in different things. So this is the primarily community that we serve, but we also serve the world, because anybody in the United States or in the world that has natural hazards data can deposit the data in DesignSafe. So I like to say that within this very the first community, or the first circle of the community, we are really embedded in it. We work together. We get their input for almost everything through our not just the advisory team and the NEARI Council, but also in the team. Within our structure, we have mostly engineers and in different, specialized in different natural hazards, and they are the ones that work with us on from design to services and data, but not data, but also the analysis. So we really get that community to make decisions about DesignSafe and also about the data depot. I'm talking in general about the data depot. So this is our team. We see each other at conferences, we provide webinars, we discuss new developments, we consult with them, they give us feedback, and so it's a very tight relationship that we have. I just happen not to be an engineer. Anyway, I just want to talk about the key capabilities. You can ask questions about that, and I'm not going to talk about all the capabilities that DesignSafe has or Data Depot has, just the ones that I will be addressing today a little bit more. So I already said that we were conceived for large data, so there's no limit at this point now to number of files or sizes per data set. There's a fluid transition within DesignSafe. It's just not a repository. There's a fluid transition between data management, analysis, and data sets curation and publication. This means that what we want is that people to start uploading the data to DesignSafe from the moment that they start their research project, and to think about DesignSafe capabilities from the moment that they design their research process. We connect the data. There are different instances in DesignSafe to tools and applications that they can use to process their data, to analyze their data. They really can gather data from the field, and if it permits, depending on the data transfer methods and the possibilities in sites that are, recently affected by natural disasters, they can stream the data to DesignSafe. And in some instances, big experimental facilities also do that from the instrument, from the moment in which an experiment is being conducted. They stream the data to DesignSafe, and then they can curate the data, organize the data within DesignSafe. So it's a data management platform. Not everybody does that, but that's what we are prepared to do. There are interactive pipelines for curation and publication. And as we said, because we address different types of research methods, we work with simulation people, with experimentalists, we work with field research specialists, with social scientists. And lately, most lately, we also publish research software, hybrid simulation, and then there's a host of other machine learning. It's a big one right now. We don't have a model for it, but we have different data models to accommodate the different structures of these data sets and to allow people to find data to represent the data within these different research methods. And you'll see it a little bit more later. We have project and data set curation and publication levels. As I said, there are big projects that may include the publication of more, or the production, or conducting more than one experiment, more than one simulation within that project. So we have the ability to describe these structures, these projects and the data sets that they produce at these different levels. We have our storage is, of course, what we call high performance storage, both for active data and for published data sets. And so at the same time that you have published a data set, you could still be managing it, versioning it, amending it, adding more data to it, adding a second batch of data, being able to do subsequent publications, and also you can be analyzing the data within your other instances in DesignSafe, other workspaces in DesignSafe. There's also, we have a registry of published data and metadata via the Fedora repository, and that's for long-term preservation. And that is really part at the back end of everything. It's part of the publication and preservation process. So those are the main capabilities at high level understanding. And I want to talk a little bit about our design process. We've always, it's a tradition, we start from a drawing. So, for example, what you see to your, is to your left, is a drawing, one of many that we did with the community that abstracts an experimental or a simulation process. I can't remember this one, what it is, but it's storm surge, I think, simulation I think it's for storm surge. So we work with the because we don't have a metadata, metadata for each one of these specialties or domain special projects. We devise model, or we have functional requirements, we have standards, and we have detailed instructions and tasks. And then our team does mock-ups. How can we represent these different projects? And we go through various iterations of understanding the mock-ups, which would be the second and the third drawing, the third and the fourth image there. So these are mock-ups, we go through them, we revise them, and we finally come up with a representation of the project, which, in this case is a simulation, structural simulation. And this is how people will be able to curate, organize the data. So it's clearly, what, there's a report, what the model for the simulation was, meaning what software they have used, what simulation software they have used. Maybe it's a community software, maybe it is developed by the users or modified by the users, and as many runs or as many components that simulation has in terms of inputs and outputs, you will be able to categorize your data and represent your data in a way that people can understand each component of that process. And the same for experiments and the same for field research. So we also have other ways of diagrams that we present in our platform so that you can really see how everything is structured clearly. And we call that research representation. So we go from instructions and this happens not only just to represent develop a data representation or a data type, but every other new feature that we have to do, we proceed with the same thinking, with the same way. We develop these functions, we draw these functions, then they're mocked up, and then we test, and sometimes even there's a usability study, and then we release them to the public. Or sometimes we release them to the public, we do a usability study, and then we go back to fix everything that may be there to fix or to improve. So I want to show you live. I don't know if I cannot show everything. You would be like, oh no, please. But we have different representations for experiments, for simulation and hybrid simulation, for field research, for research software, and then which are all the other things that are being published in DesignSafe that are not simulations, that are not experiments. So we have sometimes reports and posters. The REU students, for example, we have benchmark data sets, we have test beds, historical data sets, and we have a lot of, within that benchmark or test beds, we have a lot of machine learning training data sets that are also published. And we publish them under a model that is other. So I don't know, I guess I could show you the experimental model or engineering social science model or an interdisciplinary model, which is a field research model. I don't know if somebody wants to put in the chat what they would like to see, and then you can go by yourself and see it, but I can't show everything. I don't know if anybody wants to, or I just make the decision of what to show. I cannot see the chat from here. Oh, their chat. Let's see. If somebody has, I would be interested in research software. I will show research software, but it's the least of the interesting ones. It's about, it's GitHub represented. So this is research software, and you see that, well, is for the liquefaction earthquake database. You will see the license for software. It's already been versions. We put reference data and software because this software has been tested with different data sets, some of which are published in DesignSafe. So you have here all of these that point to you cannot, so many models, etc., are not just the software, but also you have to point to the training data set or to the data set that it was used. Some Jupyter notebooks, for example, are designed to be published. This is a Jupyter notebook, to be published independently in relation to a data set, but in this pipeline that you have your software published via GitHub. You develop your software in GitHub, and we represent it in this way. You can view the repository on GitHub. And also we are very adamant that it has to have a README file. It has to have a code meta JSON with research software metadata. and it has to be tested, and the research, the functionalities that you describe that are described in the README file, everything has to work exactly like you have written in the instructions, and we test that these, especially the README and the code meta JSON, have to be there in order for these to be published. So if you don't have a code meta JSON or a README file, you won't advance in the publication. So we have all these guardrails also. So this is the representation. It's very much like a Zenodo representation. I don't know if any of you have published, and because you cannot publish data, although a lot of people do put data in GitHub, although it just allows for a little amount, you can publish the data in DesignSafe and connect here the data with the research software in question. Let's see if somebody else has said something else, and I can, I am still showing the PowerPoint. I'm sorry. Oh, I'm sorry. I will stop sharing and share again. So sorry. Are you seeing the research software now?
Yes,
okay.
we see GUIs.
Sorry, I'm sorry. So go back again, this is the research software representation. You can view the repository on GitHub. You have to have these README code meta files, otherwise it won't be published. It won't allow you to publish, and you see all the data sets in reference data and software. Here, you may have used a model and intervened it. And you also have to have related work. This is where the software has, if it has been published, if there's a paper that you want to mention here. And the code meta file should have more metadata. Code meta is a standard for publishing research software that has all the information needed to reproduce for reproducibility purposes. How do you call dependencies or the software that you have used, etc. So somebody was at engineering then, please. So everything is engineering. So I can show you an experiment. Go back to the presentation.
Maybe like the wave facility?
The wave facility, let me see if I have one. Is that I already, to be more...
Yeah, whatever works.
Whatever works. Engineer. I'm going to just go to experimental. So an experimental project, which could be in the wave basin. This is an earthquake, a view of an earthquake. In the working directory, you have all the files that you upload, and people upload them however they want. In the curation directory, you categorize the files. You will see that we have add experiments, add categories, relate data, and every other form that you have to fill will have a lot of explanations of what you need to do and how you need to fill them. And so you have this, in this case, you have two experiments. This happens to have two experiments. And within these two experiments, you will, you will categorize into model configuration, which explains the physical experiment and the sample. You will have sensor information, and then you will have your events, meaning, for example, in a centrifuge machine, the spins, the number of events that is how the centrifuge machine spins and the conditions of that spinning. So the representation, then it's being seen in the publication preview. And here you have, this is a very simple one, but here you have how this research project with two experiments is represented. And of course, it has a report, and because this is very complex and you have certain information here, you have the description of the project at this level. The nice thing in the curation directory is that as you go, you have a lot of documentation. You can view your overview, you know, how do you do each one of the steps. Here, there's an example of how can you organize the project. So we provide a lot of onboarding and documentation. So this is what you see. And then from you know, your working directory, you can then go to your other components in the data depot, tools and applications. I'm not going to go through it, but if you have an account in DesignSafe, of course, you can go and analyze your data there. Okay. So I'm going to go back to the presentation. Let's keep moving, and then we can show more if you want, if there is in time. So what is our approach in curation and publication? It's auto-publication, just like many other repositories, but with assistance. The assistants that we call their functions. There are functions in the platform and there are functions in the people. We have interactive pipelines and guardrails. As I said, you saw one of the interactive pipelines, and we won't allow you to publish if you don't have data in your model configuration, if you don't have certain metadata fields that have to be checked or put. Now we are doing more guardrails. We want the descriptions to improve. So you have requirements and checkpoints. And of course, onboarding step-by-step guidance. We also have office hours, and that's really the meat of it, twice a week. And that's where we talk with the researchers, we give them advice, we help them organize their data, we help them understand these models, and especially we would like for every person that publishes for the first time to attend office hours. We have help documentation, a lot of it, maybe too much, help tickets that are answered by the team, depending on what you need. And we have a lot of online and in-person training. That's how we get to know the community. So I would say that our main public is the NIHIRI and adjacent communities. I say adjacent communities that are people that are from, you know, funded by other agencies, but they need to publish a lot of data like NHCI or FEAR, or, well, I say all these acronyms, but there are different initiatives that are locally funded by the state or maybe by other agents like NIH, or that also focus on natural disasters, and they don't have a place where to publish the data. In HCI, for example, they need to publish the experimental data, field observation data, and their simulation data, and we have a way to connect these two publications. And these are huge initiatives. We have New Zealand, the University of Canterbury, that studies earthquakes and landslides, and they have chosen us to be their data deposit place. So we work very tightly with them. But we also have, you know, and they constitute 40% of published projects and 80% of office hours users. But there's a little bit, the other rest of the people are people that may just publish in DesignSafe. And that creates a little bit of a tension, because we will say that the most curated data resides on our, I would say, this community, our audience, captive audience, I call them. And then we have all the others. And some of them, the publications there are a little bit, the quality of the publications, you know, even though we have all these assistants, it just depends. And they might not come to office hours. And also, I have to say that some people just want a DOI and they're desperate. But we do have something else, which is that, you know, as I said, you can publish your data, but you can also request that the data set is reviewed by a curator before publication, and we go through that through tickets or through office hours. We have a feedback form that users can fill, and they may say, there's something missing in this publication, or this research software is not working correctly. We contact the creators, and I would say that 85% of the contact after the fact is welcomed, and people do add, amend, or version their data sets according to instructions, because not everybody really looks at the help or even reads the onboarding instructions. They have the possibility to amend and control the version. And we also have a thumbs-down policy. So if people do not respond or do not want to change things, we can thumbs down if the publication has, for example, one sentence that describes the project and is totally incomprehensible and nobody answers. But in general, we have very good response, I would say. It just takes a lot of work to go through the publication after the fact. But we also acknowledge that we do not have a team of curators to curate data prior to publication. So it's a balance, and there are things in place that we are thinking about to implement to better respond to these challenges. During the day, as I say, during the office hours, the questions are around data organization, metadata fields or data reports, personally identifiable information and licenses. Access has become a big issue lately because reviewers want to download the data. You have a data download, that it uses the web download, which is obviously not good for large data sets. So they would have to have command line or other tools like CyberDuck or Globus, and that some people are more adamant to use them and some others are not. And there's a balance. I could be working with researcher forever trying to publish the perfect data set, but how much is how much, and what is nothing. So there's a balance there in terms of how much we want our data sets to be fair. And I think we achieve that, but we also have to, I cannot be working for months, although with some I do, but, I have to be very assertive, or the team has to be very assertive at the review process of telling, okay, these are all the things that you need to revisit, and not, be on, driving people crazy and myself crazy. So there's a balance there. But for the most of the times, I think that we achieve in a group, we achieve the goal, and researchers do understand the need to publish good data sets. We also are, because of that, we are also exploring AI-assisted curation and findability, because it's also hard to find, files, even if you have them all labeled, and these representations is hard because within those representations you may have thousands and thousands of files, and we have tagging capabilities, but we're working on these AI-assisted curation possibilities. We're also included in our design from inception. So these data models that you saw that lead to the metadata that is embedded in these projects and the way that data is organized correctly, we would like these to serve as training so that it can help people organize their data and they don't have to be, categorizing endlessly when it's a huge project. That is on the roadmap. So these data models were created. It's metadata. It's data models are translated into metadata that we have, structural metadata, relationship between, experiment one and all its components that could be used to train new experiments. It's not that easy because of the diversity of file formats and labeling, et cetera, that we have, and even organizing within our structure. But it's something that would need a lot of research. We have a chatbot now that is going to be soon released, I guess at the end of the next quarter. For documentation and dataset retrieval, that's in production. That's an agentic workflow that determines if the question is for documentation, if you need help and documentation in navigating all the documentation that we have, or you needed to retrieve a data set or a data point. And so these are different RAG-based AI methods that are being tested and deployed. We also want to implement, and we are researching a data description tool that suggests both appropriate keywords, proofreads, enhance the dataset descriptions and metadata. We do not want these to be like, okay, I put in the chatbot these things and, it spits a description that the user can plug in. It's another way of interacting so that you write the description and you correct the description, but it's not just spit and go. There's a process. I will be presenting some of these soon in a data curation conference. So that's the AI-assisted curation and findability project that we are working on. But I want to say that not just that, AI-assisted curation were included in our design from inception. At that time, it was machine learning, not 10 years ago. But I want to say that for the things that we are doing now for the chatbot for documentation and dataset retrieval, the role of good metadata or having a good metadata that we have tried through these models has been or is key. It's not just the good metadata, it's also the model that needs to be adjusted and the method that you use, but for AI, depending on the method, of course, and how you tune your method, this RAG-based AI method, but also the good metadata that we have been working on and the good documentation that we have been working on for years. So I'm going to go through the impact metrics. So we have, with Joshua, we have been very adamant in understanding our publications, our users, our different audiences. And so we have devised a set of impact metrics. For usage, we use make data. So what are the sources, okay? We have different, what I say is that we have different audiences to look at these metrics. We have, of course, our funders that want to, they require certain impact metrics for reporting. We have the users that want to understand whether their data sets are reused and used. That's another audience. And our audience ourselves. We really need to understand a lot, and you will see what we want to understand out of these metrics. So as a source for these metrics, as a source for the data that is behind the metrics, we have, we have make data count, citations, repository statistics, metadata statistics. So, and I'm going to gloss over, we have metrics for publications. This is publications, and just not only publications, amount of publications, but by type and natural hazards. We see growth and trends over time. We see which type of publications are the most the creators choose. And of course, other would be huge because it's everything under the sun. But then, we see these trends. We have seen how simulation has been going up. And then, of course, field research that appeared later. And the first one was experimental data. So we can see the trends. We also have usage with make data count, unique requests, and you can ask later what that means, but we have these metrics since 2022, and we ask ourselves, why those peaks and drops, and what makes these data sets popular, the highest usage. Why do we have data sets that are more used than others? I also want to clarify that here, all the metrics that we take, all the metrics are in context, meaning the issue, the difficulty with metrics is that, I mean, what are we comparing these with? If you say we have so many publications and you're like, okay, how are you comparing with other repositories? Are there other repositories for natural hazards? Are there other repositories that serve the, dedicated communities? So all of our metrics have to be in context and also with time. We cannot compare usage of a data set that was published, 3 years ago with usage of a data set that was published 1 year ago. So it's not that we compare to others, we compare against within our own community and within our project. What we can do is just see project, see process, progress, I'm sorry. Okay, we also want to interpret usage. So, make data count, statistics. We want to interpret usage. We want users to interpret usage. So when we publish in the landing pages, how much, they have, how many unique requests they have, or what's their usage, we want them to be able to understand what's their usage level in comparison to the rest of the usage within DesignSafe and in context with time. And also we are interested in, particularly me and Joshua, we are interested and we develop this bin analysis, which basically let us know whether, you say, okay, we have published something, it gets a lot of attention, and then the attention goes and nobody looks at this data set anymore. Is that true or not? And we have done these studies, and Joshua can speak more if you're interested in that during the question and answer. Citations is also very difficult. There's no good source for citations, but we have contracted Clarivates and we get citations from the Web of Science. We see also the citations of citations, which is another good way of measuring impact. And I had been analyzing first citations since 2015, and I did a lot of analysis, manual counting, and it wasn't sustainable anymore. But, in general, in total, we have 1,500 citations for DesignSafe platform and data sets. And in turn, those have been cited by other, the papers that cite those that cite the data sets have also been, this is what you see here. And one of the questions that I have been asking to, we have been trying to explore is whether there's correlation between usage and citations. And we can answer that question if you're interested. So, conclusions, we still have a lot to do. We want to better understand reuse for collection development, to understand who we need to market, what data sets are not being used, what types of data sets are not being reused, if large data sets are being used. We want to know more about our curation levels to be more uniform. We want to have a better balance between auto-curation and AI-assisted curation. So we want these to assist people. This is looking into the future, assist people to curate better. We want to reach out to non-NERI users a little bit more effectively and have them use the tools more effectively to curate data sets that they just auto-curate, and sometimes it's not perfect. We want to have to interpret these metrics. We need to have more data over time. We only have data since 2022. And of course, we have to keep working on curating and continuing platform improvement and metrics analysis. So I'm going to stop here. And I'm going to listen to your questions and here. I don't know if you have questions about metrics, about any other thing, please do. I guess it's time.
Yeah, it's time. Thank you so much, Maria. Great to have you today. We appreciate your participation,
Okay.
your presentation. Thank you.
Thank you so much.